All right, this video has to do with lesson 2, which is an introduction to variables and when do we use variables, what do they represent, how do we turn an expression and write it both symbolically from a word statement and then use it to kind of benefit us in an algebraic way. So we're going to walk through a few things that I think will be review, but will also be very good practice in moving forward in our next topic. So let's go ahead and just get going here. We got a few examples and some notes to go through just real quick. What is a variable? A variable is a quantity that may change within the context of a math problem or experiment. So something that changes. We use placeholders that are letters. So nothing new. We've done this for a while, I'm sure, in previous classes. We often use X and Y to represent generic quantities, like just to use it as a placeholder, and it could be any number could go in that spot. Here are some examples of things maybe you've seen before in previous classes. Honestly, this dates back to maybe elementary school, even, like this box, like empty spot, right? You maybe have seen that. That's not a whole lot different than using a letter. It is a variable. It's like an empty spot. It represents an unknown quantity. All right, let's keep going. Parts of an algebraic expression, some vocabulary words. An expression is really just a combination of numbers and variables in an arrangement, but there's no equal sign, no inequality either. It's just simply some arithmetic expression. All right, so right here we have a coefficient is the number that would be in front of a variable. And in between each of those right there is some multiplications going on right inside of there. And so when they're written like this, it's actually multiplication. And then in between these two terms, so you notice right here, we call that a term, and we call that a term because it's whatever separated by addition or subtraction that would be a term. All right. If it's a constant, so this word constant just means that there's no variable, it's just a flat number, all right? All right, next slide, same thing, just a different expression. Okay, we got coefficients identified by the blue right here, and this one right here, and then constants would be anything that doesn't have a variable. Doesn't matter if it's raised to an exponent or not. It's still, this is 3 terms because it's separated by addition or subtraction in between each term. All right. So this just kind of helps us think about how we're going to organize our thinking moving forward. And so some people ask, like, when is this used? How do we use all of this mathematics that we're kind of building and building and building as you go through this course and the next one and all of our math in high school? A lot of application comes sort of later on in science classes and even later math classes and stuff. But you can actually analyze the motion of anything. You can analyze trajectories of lots of different things. And people who specialize in kind of physics and things of that nature will use some of this because when it comes to like launching a rocket or throwing a basketball, or predicting some of those outcomes that have motion in 2 directions, like vertical and horizontal directions. There are these fancy equations. Do you see this fancy equation here? Those 3 and these 3 as well, which are really similar actually, describe the behavior of what's called a projectile that has 2-directional motion. All right, let's see. Okay, check out, those are those same equations. These are actually called kinematics equations. They look pretty complex, but once you start getting used to them, they're not too bad, actually. I highly recommend taking a physics class here at Coeur d'Alene High School. That we have some awesome teachers in the science department that teach physics and chemistry, and those are fun courses to take where we apply some of the stuff that we're doing in this class. What is an algebraic expression? Okay, it can have exponents, it can have adding, it can have multiplying, but at the very basic sense, it contains numbers, variables, and operations. but the operations are usually adding and subtraction. And then if you're going to multiply then or divide, then you do it directly on the variable. All right. And so this is a 3-term. And whenever there are 3 terms, we actually call this a trinomial because there's 3 individual terms going on there. All right. Let's go through some examples. This is our first example. If I was to be able to write an expression from a word problem, let's read this word problem real quick. So if we know that the water flowing into a tub is at a rate of 13 gallons, here's some important information right there, 13 gallons per minute, then what kinds of things do I know? I'm comparing 2 things. I'm comparing gallons, and I'll just say gal for gallons, and I'm comparing minutes against the time, and that's a flow rate. Often we use algebra to scale up rates of change, and so if we write down like 13 gallons right here, then per minute would be per 1 minute. And that's a comparison between, like, say, 2 different quantities. That's actually known as our unit rate. That's our rate of change. We could scale it up to like 2 minutes, and that would be 26 gallons. Ooh, we're starting to fill the tub up. 26 gallons is quite a bit of water, but most tubs, I looked it up, hold anywhere from 70 gallons to even all the way up to like 100 gallons at a full capacity. So if the faucet was flowing for 6 minutes, we could keep scaling our tub up like this, and 3 would be 13 more, and so that'd be 39 gallons, and we could go yada, yada, yada. Or instead, we could just simply take 6 minutes, and if this is 13 gallons per minute, then essentially what we could do is we could take 6 minutes and multiply it by 13 gallons, right? Because it's 13 gallons per minute, and we would, instead of taking this table and scaling it up, we could just simply multiply, and we get 13 multiplied by 6, and it looks like we're going to get 78 gallons in there after 6 minutes. That's flowing pretty fast then. 6 minutes, yeah, that's probably about right, flowing into a bathtub. All right. Write an expression to represent the number of gallons. So here's where it gets interesting with some variables. And what they're essentially saying is, if you let the number of minutes represent X, if this was X, then, and we took 6 times 13 up here, then we would actually have to take 13 multiplied by X in order to, because if you took any number of minutes right here, and you multiplied it by 13 gallons per minute, then that is exactly what we did with our arithmetic, because that would scale up the amount of gallons per any number of minutes. Whether it's 50 minutes, that would be flowing all over everywhere probably if you left the bathtub running. But what if we said, well, for X number of minutes? Because this allows us in algebra to be able to generalize things very quickly, to say, well, let's just use a variable instead of any particular number, because it could represent a variety of number of minutes that we could let the tub be filling up, right? So here's 13x, and that would be our very simple expression. All right, here, let's get a little tougher example. All right, here's the next example. And we only have 3 examples, so I'll go quickly here. Writing an expression from a word problem, again, same thing. You rented a limo to take you and your date to the homecoming dance. Oh, that's nice. The limousine company charged a flat rate fee. They actually do that, or U-Haul at least does this. I don't really know a lot about limos, actually. But let's get that one. There we go. If we had a flat rate fee of $75 per night, or maybe sometimes they say per day or whatever. And then right here we have 50 cents per mile. All right. There are 2 different ways that they're going to charge you for this. There's the flat rate fee, which is an adding on quantity. That is what we would call a constant value. This is a constant where they only charge it once. And then this is a 50 cents per mile, which is, every single mile that you put on the car, which kind of makes sense, because if you drive a really long ways, like 100 miles in one night, if you're only going to drive it around Coeur d'Alene, that's quite a bit. How much did it cost if you did go 100 miles, though? Well, you would have to take the 100 miles and you'd have to multiply it by 50 cents per mile. So it's just like 50 cents like that. And then you'd have to add on the $75 flat rate charge that they would have as well. So here's an expression. We call it an expression because there are no equal signs present. And we can evaluate this, okay? So if I was to evaluate this, I would say, how much would you pay total? Well, in my calculator, I'm going to go 50 cents, 0.5 times 100. Well, I don't really have to use my calculator because what's 0.5? That'd be half of 100 would be $50 is what they would charge you for the mileage fee. And so this would turn into 50 plus 75. Well, that's actually going to be $125 is what this would cost for 100 miles. Kind of spendy for a limo, but well, that's probably normal, actually. Who knows? How much for X number of miles? Well, what if you went 39 miles? What if you went 120 miles? What if you went any number of miles? Well, could you represent any number of miles with an X? So if I like to define my variable first, if X equals the number of miles, okay, then you have an expression that we could write. Well, right up here, what we did was the X would actually go in there because that is where our 100 miles is where we had for our first example. Well, you would actually write 50 cents per mile means multiplied by X. X number of miles goes right there. And that's multiplication if I write it next to it, right? You don't have to write multiplication in between there. It's just implied if you write it in that format, right? Like that. Okay. So then we go plus $75 as an added fee for just anybody who wants to rent the limo for any number of miles. They're going to charge that $75. There's our expression. All right. All you do for any number of miles would be to multiply by 50 cents for any number of miles and then add the $75 on because that's your extra fee. All right. So we can represent lots of different situations with variables, define that variable, and then write an expression when you know that the value of that variable can probably vary quite a bit. Get it? Like variables vary, things change. There's lots of numbers that could be for the number of miles that you could travel. All right, next one. Let's see here. Erase. Okay. This is our last question. So this is totally different than anything that we've done in this section yet, but we want to practice this skill. And it's not a whole lot different than doing order of operations. If you see a variable that looks like this, let's just go through each of these examples. I'll go quickly. All right. So the first example, we'll go here, 12K minus H squared. Okay. Then there's this semicolon, which separates it from all this other stuff. H equals 2. That just means that H is going to be substituted. We're going to say that it equals 2, which means put it in right there. Okay. Then this one equals 3. Put that one in right there. Okay. So all I do is rewrite it. So I'm going to rewrite it right like this. And I'm going to say 12 is now going to be multiplied by 3. Because I'm going to put it in where K is. I like to do the parentheses, and that just emphasizes that I'm actually substituting it into that location. Some people like to show less work and actually just call it 36, and you do the multiplication out. Well, I like to actually show my work a little bit and rewrite this step. Okay, and I like where there was a variable, I like to make an empty spot using the parentheses like that. Okay, then it will be squared, because the H was squared. So the empty spot is squared as well. So I put a 2 in there, right like that. And then I'm going to evaluate this no different than order of operations PEMDAS, now that I have my numbers in there. So this is really not a whole lot different than some of the stuff we did yesterday, but there are variables and you got to plug the numbers into the spots that they go and do it in the right order. I'm going to write PEMDAS up here. PEMDAS. DOS. And remember, multiplying and dividing can go in either order as long as you're going left to right. So I like when I write PEMDAS to go like this, left to right, and add subtract left to right. Okay, so but parentheses are always first, then exponents. Well, this parentheses doesn't have anything going on inside of it. It's just squared. All right, so I'm going to do that first. You could technically, once you get better at this stuff, you can realize that this can actually be done as well, because that would be your next step. And so I'm just going to rewrite, because I know I'm going to rewrite it as a multiply, right, like that. And then minus 2 squared would be 4. All right, next step would be to take 12 times 3, which is 12, 24, 36. All right, so there'd be 36. That's my multiply. Okay, then I'm going to subtract 4. I like to rewrite it. Remember, funneling it down to that answer. All right, I don't even mind if you put on the little sidebars like that. Helps out, I think. 32 would be our final answer, right, like that. Put a box or a circle or something around your final answer. It lets us know what to look for. All right. Okay, next one. Let's do this crazy one over here. All right. There are some parentheses. There's an exponent. There's all sorts of stuff. But this p equals 1 is the first thing we're going to evaluate. That goes in to the p location. Look for more than one spot, too. There might be multiple p's. In this case, there is not. But it goes in right there. 1 does, right? So if I was to rewrite it, 1 would go right there. Okay, and then actually I'm going to erase that real quick. Oh, well, rewind the video if you want that other one. All right, so this one right here, p equals 1, and q will equal 1 as well, which is kind of nice. Here, we'll make that one orange. Okay, so that one goes in right there. Okay, let's rewrite these, and we're going to go 1 plus 1. And I'm going to put my parentheses, and I'm going to square it, and I'm going to minus. I'm just rewriting stuff, carrying it down, and there is huge value in being able to just rewrite it, all right, with all the numbers in, no variables, just put all the numbers in, and just rewrite it so that we can do this. 1 plus 1 inside the parentheses. Remember, PEMDAS, right? And left to right, left to right. Okay, so 1 plus 1 is 2, so I'm going to write 2 squared. I can even drop my parentheses because the squared is on the outside of the parentheses, which means it will be on the outside of that single number that I can drop down. Minus 5 minus 5 is 0. All right, so it's getting a whole lot simpler very quickly. All right, and then I could do my exponent after my parentheses, and I go 2 squared. 2 squared is 2 multiplied by 2, all right, which is 4 minus 0. Well, really, do I need to rewrite all that? No, probably not. You notice I'm funneling my answer down to a final answer, okay? Put a box around it or a circle or something. Identify that that's your final answer. Okay, last one. Let's plug in h equals 6 and j equals 4. H equals 6 will go in there. Put a 6 into that spot. And then a 4 would go into this spot right here. Okay, so we go like this. We go 6 plus, and I like to make a void or a vacancy using some parentheses so that I know I get it into the right spot with a squared on it, right, like that. Okay, and then I go minus and another vacancy or a void where the 4 goes right there. And then I can close that other parentheses around the whole thing. Although if you have parentheses around the whole thing, all that really means is that the dividing will be on all of that at the very end. Okay, so let's clear the inside parentheses first. And again, if you don't like the way that I wrote the 6 with the parentheses, you don't have to. You can just write it as a 6 squared, right, like that. No big deal. All right, so let's rewrite this. Okay, and I'm going to clear some of the parentheses. Okay, so that means that, or I'm going to do the exponent here first. So 6, keep these parentheses on, plus 6 squared is 6 times 6. 6 times 6 equals 36. Okay, so I rewrite it as 36 minus 4. And I could drop those parentheses. You don't have to put those on. I just kind of like it because it emphasizes that it used to be a J and now it's going to be a 4. And sometimes there's a negative value on like that 4 right there, and so ignore that. But so sometimes you want to put a negative inside of the parentheses with it, and it gets kind of crazy like that, right? Okay, now next step, we did the inside of the parentheses. We're clearing that. So before I get to the outside of the parentheses and the dividing by 2, I need to do all of this part. I'm still here. I'm doing all of the inside of the parentheses to get it to simplify to one answer. Okay, so now since I'm adding and subtracting inside the parentheses, I'm going to go left to right. 6 plus 36 is going to be 42. Yeah. And I like to rewrite it. Remember, only do 2 numbers at once. That one goes together with that one, and it makes 42 minus 4. And I still have my parentheses on the outside, divided by 2. Okay, I'm going step by step and rewriting it and making sure that I'm getting it exactly right. 42 minus 4 is going to be 38. And so we have 38 divided by 2. Now I can drop my parentheses because it simplified to one single number. All right, it's kind of nice. There's not a lot of negatives going on, just some regular old subtracting. These are some easier examples a little bit. 38 divided by 2. What is the final answer? 38 divided by 2 would be 19. Final answer, 19. Put a box around it. Okay, you can see how I organized myself by allowing it to kind of funnel down and get to one single answer at the very end. Simplify, simplify, simplify. Rewrite it, as many times as needed. Don't do too many steps at once. Just do like one step and then rewrite, one step and then rewrite it. Okay, I think that's our last example and our last topic. Yep, sure is. And so, awesome. There's a couple other videos that will be in here with this. This one's a little bit longer, so fast forward, rewind as needed. All right, keep up the hard work. You guys are doing awesome.